when astronomers once again began talking about the mysterious object designated 3I Atlas in March 2025, curiosity ignited across the scientific community. It felt as if history was repeating itself. Another interstellar wanderer had entered our skies, following in the strange footsteps of Oumuamua and Comet Borisov. But 3I Atlas was not just another guest. Its behavior, trajectory, and structure raised the same deep questions humanity still struggles to answer. What exactly visits us from the depths of interstellar space, and what does it reveal about our place in the cosmos? From the moment of its discovery, 3I Atlas puzzled observers. Its path clearly indicated an origin beyond the solar system. It was moving too fast to be gravitationally bound to the sun. It appeared suddenly, swept through the inner system, and began to depart again, like a traveler pausing briefly beside our star. It soon became clear. This was the third known interstellar visitor, proof that such objects reach us more often than once imagined. Scientists at NASA, Harvard, and the European Space Agency began collecting every possible measurement. Early data showed a highly elongated orbit and a peculiar brightness. As it approached the sun, the object displayed comet-like activity, sublimation of ices, yet the intensity of this activity fluctuated. At times it shone brighter than predicted, then dimmed almost completely. These inconsistencies sparked a wave of hypotheses. NASA's official stance remained cautious. Most researchers considered 3I Atlas a comet losing material as it neared the sun. Yet several facts didn't fit. Measurements suggested its density was extremely low, perhaps less than 1/10 that of water. Some data hinted it might be porous like a sponge, or even a fragment of a shattered interstellar world, perhaps once part of a planet's core. Others, however, saw deeper puzzles. Among them was Avi Loeb, the Harvard astrophysicist known for bold ideas about interstellar objects. He had already argued that the first such visitor, Oumuamua, might not be natural at all, possibly an artificial relic from another civilization. Now, with 3I Atlas, Loeb again urged scientists not to dismiss unconventional possibilities. To him, these travelers could represent a far wider diversity than traditional models allow. Perhaps not mere comets, but messages from processes beyond human understanding. Meanwhile, other astronomers proposed more traditional explanations. Some suggested 3I Atlas was a fragment torn from another planetary system by a massive star's gravity. Such events are common throughout the galaxy. In young systems, gravitational chaos often ejects planets and debris into interstellar space. 3I Atlas, they said, might simply be a cosmic vagabond, drifting for millions of years before crossing paths with the sun. At the European Southern Observatory, scientists noticed that its reflectivity changed irregularly. The object scattered light unevenly, as though covered by materials of varying composition. Perhaps it was made of volatile ices partially evaporating with heat, yet its brightness didn't match standard comet models. These deviations revived interest in more daring ideas. At Harvard, Orbital calculations showed that 3I Atlas followed an unusually clean trajectory for a random fragment. Some parameters hinted at a non-gravitational acceleration, similar to what had been seen with Oumuamua. Loeb once proposed that such acceleration might result from radiation pressure, as if sunlight were pushing against a thin, flat surface, like a light sail. Now 3I Atlas exhibited the same effect, though more subtle. NASA's Jet Propulsion Laboratory approached the issue conservatively. They noted that outgassing of volatile materials, hydrogen, carbon dioxide, methane, could in principle create a similar push. Yet the math didn't fully agree. To produce the observed acceleration, the comet would need to emit far more gas than detected. No visible trail of vapor or dust accompanied it. Dr. Karen Michelson of ESA proposed another angle. Perhaps interstellar objects undergo such extreme physical aging that they lose typical cometary traits. After millions of years of cosmic radiation and micrometeorite impacts, their surfaces could form a dense crust, preventing ordinary sublimation. This would explain the weak activity, though not entirely. Debate flared again. Some argued that 3I Atlas proved countless such bodies wander through the Milky Way, unseen until now. Others pointed out that the repetition of similar anomalies with both Oumuamua and Atlas was too suspicious to ignore. Their trajectories and properties were oddly alike. Maybe we were glimpsing a whole class of interstellar objects whose true nature remains hidden. A few theorists even speculated that these could be fragments of lost technologies, remnants of civilizations long vanished. Not in a sensational way, but in a statistical sense. If life arises throughout the galaxy, some intelligent species would have reached the stars long before us. Their relics could be drifting silently between suns, mistaken for comets. Most scientists, though, preferred more grounded views. Dr. Amy Simon of NASA emphasized that 3I Atlas offered a unique chance to study how objects form and survive beyond our system. Such bodies might carry the same chemical ingredients found everywhere in the galaxy, the universal building blocks of life, scattered through space for billions of years. In that sense, each interstellar traveler is a messenger of cosmic chemistry, a record of the matter from which planets and living beings arise. Researchers at the University of Hawaii added that tracking 3I Atlas refines our understanding of how often interstellar visitors appear. If in only a few decades we've already seen 3, Oumuamua, Borisov, and Atlas, there could be thousands more passing unnoticed, too faint for our telescopes. For Avi Loeb and colleagues, that reinforces the idea that interstellar wanderers are not exceptions but a common phenomenon. With vigilant observation, humanity might one day send a probe to one of them. The Galileo project at Harvard is already exploring designs for miniature interceptors that could launch when the next such object is spotted, potentially making history as our first physical encounter not with a civilization, but with its ancient technological echo. Meanwhile, NASA analysts continue to sift through archival data. Some models suggest that 3I Atlas passed near other solar bodies, slightly altering its path. Others imply it could be over 1 billion years old, originating from a dense stellar region, perhaps the galactic center itself. If so, we are witnessing a traveler older than our species, older even than Earth's continents. Even the most cautious scientists admit that 3I Atlas challenges our understanding. We still don't know what these interstellar objects truly are, why their shapes and brightness vary so wildly, or what forces guide their journeys. But that very mystery is what makes them precious. Each one pushes the boundaries of what we think we know about the universe. Maybe 3I Atlas is nothing more than a lost shard drifting in eternal darkness. Or maybe it carries the story of worlds long gone, chemistry from alien suns, frozen records of cataclysms older than the solar system itself. Perhaps it is simply a reminder that we are not alone, and that the universe is far richer than we can imagine. One thing is certain, with every discovery like 3I Atlas, our horizon widens. We see that space is not empty, but alive, a vast ocean of motion and exchange, a history written in starlight. And perhaps one day, another such traveler will bring us the answer we seek, not about who we are, but about how ancient and diverse intelligence in the cosmos might truly be.